It's math time with Mr. Mock. It's math time with Mr. Mock. It's math time. Hey, Math 8. It's Mr. Mock coming at you with another video. We're jumping into Unit 2. And the objective for today, tomorrow, is that you're going to be able to use scale on a circular grid. All right? So let's first off, we just had a 2-week little mini project. Let's get back and talk about rigid motion. Rigid motion is when we're taking that shape, and we talked about transformations, which included translations, rotations, reflections. And when you use rigid motion, the shape just moves on a plane. Maybe it reflects, maybe it rotates, but the shape stays the same. It's congruent, right? So rigid motion is when a shape translates, remember that slides, rotates, and reflects, and or reflects on a plane. Okay? Basically, this shape is congruent. The shape stays congruent. Right? Now that's huge. And that's was like the main thing from Unit 1 is we're moving that shape around, and as it's moving, it is the exact same. The angles, the side lengths, everything is the same. So there's those corresponding parts, okay? Now, so that's rigid motion. We're moving with Unit 2 into dilation and scale, all right? So now with scale, scale is used to make objects bigger or smaller. So when you think about scale, one example I always come up with is when we were moving to Washington from Alaska, we stopped in Seattle. We went to this Space Needle. We did that whole thing. And in the Space Needle, in a little gift shop, you can buy a little Lego miniature Space Needle, right? It's smaller. And there's always those little models. You can get a little mini Space Needle when you go to the gift shop, right? So, and that is a scaled down version. Everything about it is pretty much the same, except it's just smaller. The dimensions are scaled down. You can take something and scale it up, all right? So when I'm thinking about scale, I like to think about it like shrinking, going up, shrinking or going bigger, right? So when we're looking at scale, scale is used to make objects bigger or smaller. And so I've drawn this little triangle here, right? Even gave you the angles, 50 degrees, 60 degrees, 70 degrees. This one's 2.75 centimeters. This is 2.5 centimeters. This is 3 centimeters. And I want to increase it by a scale of 3. Increase it by a scale of 3. And in your mind, or even if you want to pause, actually, let's do that. Let's pause, and I want you to think about what would the lengths be if I'm increasing this triangle by a scale of 3. So go ahead and pause and give that a think. Okay, so hopefully you gave that a think. And this is what you should have gotten. When we're increasing it by a scale of 3, that means every length is going to be multiplied by 3. All right, so this length here is going to be 3 times 3, which is 9 centimeters. Okay, 2.5 times 3. Well, 2.5 and 2.5 is 5. 5 plus another 2.5 is going to be 7.5. Right? And then 2.75 times 3. You can do this however you'd like. You can think of it as 2.5 plus 2.5 plus 2.5. We already know is 7.5, but then we'd have another 75 cents, right? Because it's 0.25, 0.25, 0.25 3 times. So it'd be another 75 cents. Or you could just take out your handy dandy trusty rusty calculator, do 2.75 times 3. And this is going to be 8.25 centimeters. All right. So basically, you've taken that little triangle and multiplied it by 3. That's when we use the scale. We multiply it by 3. Boom. It's 3 times bigger. All right. Now, what do you think of the angles? Do the angles become 3 times bigger? Is this 150 degrees? Is that 120 degrees? Is that 210 degrees? No, that doesn't make sense. Those would be like huge angles, right? So here's the thing with scale. The angles stay the same. All right. So this is still 50 degrees. This is still 60 degrees. This is still 70 degrees. Those angles are the same. All we're doing is increasing the lengths. So maybe make that note on your page. All right. Now, hopefully you've been pausing, following along and writing down these notes. You also, I did include a picture of these blank that you can then fill out as you watch the movie. I did type that in Google Classroom, so hopefully you saw that. If you are able to print these out, awesome. If not, you can save them, put them in a Word document, or even would be best, a slide, and then type over it. You can do that as well if you want to just type it out. That's an idea, okay? So now, we're going to keep going. We're going to look at this rectangle now. And I want you to decrease that by a 1/3 scale. So we're going to dilate it by 1/3 scale. And I want you to go ahead and pause and give that a think, okay? Pause and give that a think. Okay, so if we're using a 1/3 scale, you've got your little triangle or a little rectangle here. You're basically saying this side is going to be 9 times 1/3. But when you multiply by 1/3, that's the exact same thing as dividing by 3. So really, 1/3 of 9 is the same as saying 9 divided by 3. So this would be 3 inches. Then 15 times 1/3 is the same as doing 15 divided by 3. This would be 5 inches. Okay, so nice job. And so that's how you would use scale. Now, again, the angles would be the same, right? We can't make those 1/3 of 90. I mean, then it's no longer going to be a rectangle. The rectangle has to keep the angles, right? All right, so we're going to go ahead, and now I'm going to turn my page. And I'm going to show you this cool thing. This is called a circular grid. You see that? All right. Now, I've included a picture of this in the Google Classroom notes. And your objective is to use this grid. And I want you to dilate this triangle by a factor of 2. And let's make a note here, using point P as the center of dilation. All right. Using point P as the center of dilation. All right, that's a key note there. Point P is the center of dilation, and we're going to scale this by a factor, or dilate it by a factor of 2. I want you to go ahead and work on this and then bring it to rotation tomorrow. All right, team, that's everything. Hope you've enjoyed another video with Mr. Mock. It's math time. Bye, team. Video over. Mock out.